Swayam Prabha. Digital India. Educated India.
Alright guys, in the previous videos you had seen how we can get the input and check if it is a valid input, and then once the input is valid we'll proceed with how to check for the weekday, that is the day of the week on which the particular date falls. So we had inputted the year, anything from and after 1970 is allowed, and we had inputted the month. The allowed range of values is from 1 to 12, and we had inputted the date. The valid date factor varies based on if it is a leap year, the month, the date, month, year. Based on all these factors, your fact that the date is valid or not varies. We had seen how the variation is. All this we had seen in the previous videos. Also I had explained in the slides as well. That is what we had coded. From the slides maybe you can try coding it in your own, and you can see how the similarities or differences between your approach and my approach exist, and you can discuss all these things in the discussion forum. Just that given that there are so many constraints, it may appear that it's very complex or something, but nothing. It's just that my way of wiring the conditions is like this. There can be multiple ways. You try wiring by yourself, you'll understand that it's very easy. Alright, so by now you have got the input of year, month and date that is needed for our built-in function. That built-in function is found in the library calendar. So let me import that first so that I can use it. That is my ultimate purpose of this exercise. I'll import calendar. Right. So I had imported calendar. So now I'll be using it. So this functionality weekday present in calendar is what will return us what is the day of the week given a date. Right. So we had seen how the signature of it, we had seen how to use it in our prerequisite videos. We'll revisit it now. So one thing that we had noticed that it returns the index. It says 0 for Monday and 1 for Tuesday and so on till 6 for Sunday. This is how it returns your input. It returns the output in this fashion. 0 for Monday to 6 for Sunday. 0 for Monday, 1 for Tuesday, 2 for Wednesday and so on till 6 for Sunday. This is how the calendar.weekday, the weekday functionality that is present in the calendar library works. But that is difficult for humans to interpret, so we need to convert that as well. So first thing what we have to do is we have to get that index, whatever it is returning. So let me say day index. Day index is returned by this thing, calendar dot weekday. Calendar dot weekday of, see the arguments are year, comma month, comma day. Day is nothing but the date. Year, comma month, comma date. Okay. So we had inputted it. We had sent the inputs for this functionality to work. So it will work. It will return an index which will say which day it is. 0 is for Monday, 1 is for Tuesday and so on till 6 is for Sunday. But that is not easy for humans, right? So we'll have to get the day from this day index. So let me say day, I have to get it from day index. I'll say get day. I have to get day from day index. Day index. Right. See, there is a warning symbol which says that it's undefined. That is, I've just said the name. I haven't defined what this has to do. So let us define it. So let us just define here. It's fine. Define get day. Let me define it. So what is the list of days? let me say list of days. The encoding is, it starts from Monday. 0 is for Monday, right? So let me say Monday, Tuesday, Wednesday, Thursday, Friday, Saturday and Sunday. So this is the order in which it encodes, right? Monday is encoded as 0, Tuesday is encoded as 1, and Wednesday is encoded as 2, and so on till Sunday is encoded as 6. So I have created a list of days basically. So I guess you would understand, you could figure out what will be my next step. I'll just return. So okay, for this, yes, I need to have the day index, right? So day index, I need to have the day index. So I'll just return the corresponding value from this list given by day index. List of days of day index. This is the most simplest definition. I guess you are able to understand it. The encoding is 0 is for Monday, 1 is for Tuesday, and so on till 6 is for Sunday. This is how the lists have their indexing mechanism. So we are creating a list of days, and whatever is the index that is being passed, we will pass the corresponding element in that index as the output. That is, if the passed index is 3, then 0, 1, 2, 3. It's 0, 1, 2, 3. It's Thursday. Thursday will be taken as the output. So we will get the name of the day here. So that is obtained. So now we have to print the answer. Let me print. I'll print a very good message. I'll say date. This is how humans do it, right? By a slash we'll separate it. Date, month, then we have another slash, and year. This is our human friendly format, so I am printing in that human friendly format only. I'll say it falls on this particular day. It is captured in this variable day. So this falls on this particular day. This is how the working is. Simple. We'll just give a very quick summary and then we'll go ahead with running of this code. See, I'm getting an input of year. I'm getting a year. I'm inputting year. If it is after or from 1970, I agree that input. And I'm inputting month. That should be in a range 1 to 12. And I'm inputting date, and based on the factors, if it is a leap year and what is the month that is being entered, I determine if the entered date is a valid date or not. Then based on this, I'm inputting some date, month and year, right? So based on these things, I'm now passing it to the built-in functionality calendar.weekday. In calendar library, you have the functionality weekday. We are passing this and it is returning an index. It's not returning the name of the day, it's returning the index. So for getting the name of the day, I am using the list mechanism and I am getting the day, and after getting the day, I am printing that this particular date, month, year falls on this day. This is how the working is. Okay, let me save it and let me run. Okay, so it's asking me to enter a year. So let me say 2000. Let me enter a month. Let me say 4 April. Let me enter a date. Let me say 25. Okay. 25/4/2000 falls on Tuesday. I got an output. So like this you can check for any dates. Once your program is ready, running is, see, as you could see, maximum it would have taken half a second. That's it. It's all the delay by which you are giving your input. That's it. If you hard code the input, if it is to be read from the code itself, it would be really within fraction of seconds. So this is really very fast way by which you can know the day of the week given a date. Alright guys, so we had seen one task. We'll see another task that we can do using these cool Python libraries in the next part of the video. Alright guys, so that was a very good exercise. Given a date, you can quickly say on what day this particular date falls on. So that is really very cool functionality that Python provides. And now we'll see another task. So this is the task. If the current time is known as per your time zone, can you say what is the time in other time zone based on different time zones? I have to know the current time. That is, I can get the system time from a command as I had discussed in the prerequisite video. For all the time zones, can I get the time? So to get the current time, as we had used the date time library, we will be using that. And to work with the time zones, we will be using this library PyTZ, TZ for time zone, Py for Python, TZ, PyTZ. We will be getting the current time and we'll display the time as per the different time zones as an output. So that is what we'll be doing in our task. We'll see that in the next video. Alright guys, so in this Joy Fun with Calendars, we had seen some cool tasks that can be done using the libraries provided by Python. We had seen them in the prerequisites. Also we had seen a task of given a date, can you predict which day of the week that date falls on? We have seen that. So the next task that we are going to see is you have to fetch the current time not only in the time zone that is followed in your current location, but as per the time zones across the world. That is, what are all the time zones that is present? I need to get the time as per all those time zones. That's what I want to do. So let me do that. So as we had seen, to get the current time, we need to use the date time library. So that is a superset as well as a subset, as I had discussed in the prerequisites video. We just want to work with the subset, so let's import it from the superset date time library. Import the subset date time library as dt. Because the name is lengthier, so I am using a short name as dt. So that this is to get the current time, and we are going to work with time zones as well. So let me import the library PyTZ, Py for Python, TZ for time zone. So let me import this as well. So the first thing I have to do is I have to get the list of all the time zones. So let me call that as time zones. Time zones is nothing but it is given by this built-in functionality in PyTZ library. Just say PyTZ dot all underscore time zones. So if you just say that, you'll get the list of all time zones here. So now simple, it's just iterating through the list. We have the list of all time zones, and we know given a time zone, we can fetch the current time as per that time zone. So we are just going to iterate through this list, and then we are going to display the time corresponding to each time zone in this list. So let us iterate it. So I'll say for I in range length of this list. The name of the list is time zones. Just iterate over this list. So my current zone is nothing but at the ith element, right? So I'm picking the current zone. I'm iterating over the list. I'm picking the current element where I am standing. I'm picking the current position element. So I have picked the current zone. So now I should create a time zone instance, time zone object, a special object to work with time zones. As we have seen in the prerequisite video, we will be creating a special object. So let me say TZ, time zone, a convenient representation. Pi TZ, the library name, dot time zone is the functionality. And what is the time zone that I need? It is given by the variable zone. This particular time zone is what I need. So I have created an object, and now I can print the current time easily, right? So I'll print current time at zone. What is the zone? That is given by the variable zone is the current time. How will we get it? From this datetime library dt dot now is the functionality, and to this functionality I need to pass this time zone object tz. So I have passed it, and so I got the time zone now, right? So that's it. Just we can get the list of all the time zones from this library, pi tz, pi for Python and tz for time zone. We can get all the time zones, and we are iterating over this list, creating a time zone object, a special object by which you can work at that time zone irrespective of whatever is your current location. A special time zone object we are creating, and we are passing that to the functionality that fetches the current time, so that it fetches the time as per that time zone, and then we are printing the fetched time. That's what we are doing, just simply iterating over the list. I hope from the prerequisites video, if you are very clear, and from the slides that I had discussed, given the task, it's very easy. You can easily connect the dots and you can come up with this code. This is really very easy. See, the code is just some 8 lines probably. There are some spaces in between, so some 6-7 lines of code. That's it. That's what we are using. But what is the magic it's doing? You will understand if you get the output. So let me save this. Let me run this code. See, I'm getting the output. Oh my god. So, wow, so fast. It's done. See, the 500 plus time zones as we had seen, everything is outputted just in fraction of seconds. That's the magic. So you can know the time at any place in fraction of seconds by using your Python programming skills. Alright guys, I hope you enjoyed this series on fun with calendars. Thanks for watching. Have a nice day.
We are now going to discuss one of the most celebrated ideas in computer science. I would say it is one of the most celebrated ideas, heavily applied idea in the whole of mankind. I get to say this because of the simplicity of the idea, yet it has tremendous applications. You will soon get to know what I am going to talk about, but before which, let us start our lesson with a small activity. The activity comprises of a bunch of students trying to talk to each other, and then they make a note of who all they were impressed with. For example, a person will go and talk to 20 others and make a note of a list of people that she was impressed with. So, and every single person does the same. All 20 people do this, write down the names of people they are impressed with, and they give it to us. Now, we create what is called the impression network. Who likes whom? It looks like this on 20 notes. And now we ask this question. This impression is more like voting. I like him. I like her. Based on this, can we pick a leader amongst these 20 people? First question. How do you pick a leader? Second question. Why is it important for us to even ask this question? Why is this the most celebrated ideas of all times? You will soon get to know after watching this activity.
saw a group of people were asked to choose their leader. Each one of them was asked to select around 5 people to whom they wanted to be their leader. And now we have the leader of the group here. Congratulations, Virinder. You have been selected as the leader of the group.
Thank you so much. It will be a proud privilege for me.
How did you convince these many people to vote for you?
Actually, convincing them, it's not a big task, what I feel personally.
Yeah.
The thing is that, first of all, I introduce myself, that what type of problems they are facing actually, whether they are from research side, whether they are from graduation side, that what type of problems they are facing in their hostel life, in their career life. So by asking all these and giving some good suggestions, so I think I will be connecting them very properly.
Yeah, so
So due to that reason, so due to them, I think I feel that they choose me as maximum as possible.
Oh, good. So can you guess how many votes did you get?
Definitely many.
Okay, you got many votes, but let me tell you one thing. It's not only the number of votes that made you the leader, but it's also about the people who voted for you.
I didn't get you. It's the number of votes that serve as a deciding factor in every election. But how this?
Let me explain you PageRank algorithm. So take an example. Suppose you and your friend are applying for a promotion. Both of you are working in a company. So many of your colleagues have referred to your friend for the promotion, but your manager and group they have referred you. Who has high chances to be promoted?
I think me.
Okay, so now you see, the number of people who are referring doesn't matter. It also matters who is referring to you. So this is the PageRank algorithm, and the Google also works on this very simple
cool.
algorithm.
That's really cool.
Yeah. So in Google, we have an underlying web graph where the nodes are the web pages and the links are the hyperlinks. Meaning if one page is referring to another page through a hyperlink, we will connect it through the edges.
Okay.
And then Google run PageRank algorithm to find out the top nodes.
That's really cool.
Yeah.
I really like this thing.
Yeah. So congratulations again.
Thank you so much.
And we have a small gift for you
Thank you so
to
much.
win the
Thank you so much.
election.
Thank you.
You know what I'm going to do with this data? I now have what is called a network. And my network looks like this. Do you see the nodes here and the edges? Look at this arrow from this node to this node. It just represents that this person found this person impressive. If A finds B impressive, B may not find A impressive. Correct? Now, my question is, how do you find the most impressive person here in this network? An obvious answer that we will have is, look at that person who has a lot of arrows coming in. By that we mean many people found him impressive. A number of people finding someone impressive should not be an indication of how impressive a person is. For example, assume 100 friends of mine says, I am a nice person. That is different from the Prime Minister of India saying, I am a nice person in one of his speeches. Right? There's a huge difference. So what do you infer? It is not how many people who vote for you. It's about who are those people who vote for you. Maybe we should consider that. Right? So now on this network, I would like to ask this question. Who is the most impressive person? And I'm going to give you a technique to find it. You may not even see why exactly we are using this technique to find the most impressive person, but with time it will be very clear. Here goes my algorithm. Here goes my technique. What I will do is, on this graph that you are seeing, the network, I will start from some node and take what is called a drunkard's walk. Also called the random walk. The point is, you start from a node, let's say this node. You have so many lines going from this node. Forget about what this network represents. I'm going to play around with this network. I'm going to jump to one of the lines and land at the other end of this line, the point whatever you are seeing, I'm going to land there. But I have so many choices to take, I will pick one of them randomly. And then I jump there. Once I jump there, I mark 1 here, saying that I have seen it already. And from here, I'll jump to another node. Again, from here, there are many lines going out. I will choose one of them randomly and jump there and call it I have visited this once. I keep doing this. If I visit a node more than once, I'll make a note of it and call it I visited this node twice, and so on. And finally, I do this, let's say, 1,000,000 times. If I'm not happy, I'll do it a couple of million times or even more than that. And after doing this 1,000,000 times, I will see what is the points collected by individual nodes. And I will look at that node which has collected the maximum number of points. And I'll declare that node as the winner. Why do I do this? What does this signify? You will get to know very soon. Now, we had a bunch of people and we asked them to take part in an activity. And then we drew a network from them and did what is called random walking on the network. I asked you to do it, right? We'll show you how to do it right now. But one should do this random walk and then see the points accumulated per node. And then look at that node with the highest point and then call that fellow a leader. Now, you know what? This is precisely how your Google search engine works. And this algorithm is called the PageRank algorithm. So, what is the connection? Look at this. Look at this network and take a random walk on it. What are those nodes which will have highest number of visits? It's going to be those nodes which are easily reachable when you're taking random walks. How do you reach a node? It should be easy to reach their neighbors. How can you reach their neighbors? It should be easy to reach their neighbors' neighbors. The most popular person's neighbors. So, if there's an easy incoming way to a node, then that node will have a very high weight. So, intuitively speaking, a person is important if important people point to him. A node will get a lot of weight if it is adjacent to a few nodes, and these few nodes are all important. By important we mean they are adjacent to a lot more nodes. A node is adjacent to many nodes and these nodes are adjacent to many nodes and so on. Correct? So, we are just giving you a very toned down version of PageRank because it's a first course in programming. We don't want to bother you with a lot of details. But if you're interested, you can take a look at our course on NPTEL called the Social Networks course. There, we describe in detail, one entire week we discuss on how PageRank works. So, getting back, we have now told you how to take random walk on a network, increment the points individually on the nodes, and look at the top nodes thus obtained. They are the most important nodes. Now, how does Google work based on this idea? It's very simple. What Google does is, as you can see in this animation, it takes a website. And on that website, as you know, given a website, it will have a lot of hyperlinks to another website. By hyperlinks, we mean a place where you go and you click and it takes you to another page. You see, that's called a hyperlink. Okay, so I will take all possible web pages in the world that one can think of, and I will put an arrow from a web page to another web page if there's a link from this web page to this web page, and I'll create this huge network. By the way, this is how the network of internet looks like, where a line between two nodes, where nodes represent websites, and a line between two nodes represent that there is a link from this site to that site. This was the snapshot of the internet long back. Of course, it has grown bigger right now. It looks even more complicated right now. But just for completeness sake, we are flashing the network of the internet. This is called the World Wide Web Network. So now here what Google does is it takes all these pages of the world and runs a random walk on it. It's a huge network, you see. It takes a long time to run random walk. Of course, with sophisticated computers, you can do this. A huge network on billions of nodes, you run random walk and you make a note of how many times you visit a node as you are taking random walk. As we are talking now, as you are listening to this video, Google actually is doing this. It is taking all the websites of the world and then taking random walks on it. Okay, you would have heard of crawlers. This is precisely what we mean by crawlers. There is a program which crawls through the web like this and makes note of how many times I visited what node and ranks all the nodes based on the visits to the node. Okay, now when you type the word, let's say Mysore city, right? It will look at all those websites which has the word Mysore, and then it will realize that there are 10,000 websites that has Mysore in it, but it will show you the top few sites that have accumulated top points due to this random walk. You may want to get that straight. Let me repeat. So when you type Mysore, there are 10,000 hits, 10,000 sites which has Mysore in it. But then Google will fetch the top few sites to you. How does it know what are the top few sites? Top few sites based on the points accumulated because of random walk. That's it. This single idea has led to a $500 billion industry today. Google, as it stands tall, mainly started off with this very algorithm, which till date is the best possible searching technology. Of course, there are several other parameters that a search engine uses, but the basic heart, the nucleus of the idea is whatever we taught you so far. Now, let us go ahead and look at the nitty-gritties of how to take a random walk and then how to crawl on a network.
Hello all, welcome to the programming screencast of PageRank. I hope it is now clear to all of you what is PageRank. PageRank is basically an algorithm that is used to rank nodes in a given graph. In this particular programming screencast, I'll be telling you how can you find out PageRank from random walk method using random walk method. So first of all, let me tell you what is random walk. As the name suggests, when you have to traverse the graph randomly, it is called a random walk. You pick any node from the graph randomly and look for its outlinks and traverse one of its outlinks randomly. Then you look for the outlinks of the present node and then traverse one of its outlinks randomly. In this way, you traverse the whole graph if it is connected, obviously. So I'll be giving you an example and it will become clear to you what is random walk. So as you can see, we have been given a graph here in which we have A, B, C, D, E, F and G as the set of nodes. So first of all, I'll initialize the counter of each of the nodes. So I have initialized the counter of each node as 0. Then I'll pick a node randomly from the given set of nodes. So I picked A here and I incremented its counter 2. Then I will look for the neighbors of A. What are the neighbors of A? We have B, we have F and we have G. We have to pick a node randomly from the neighbors of A. So we will pick a node randomly and we have selected F and we have incremented its counter 2. Then we will look for the neighbors of F. What are the neighbors of F? We have G, we have E. So we will pick a node randomly from the set of neighbors of F and increment its counter 2. So we have picked E and we have incremented its counter 2. Then what are the neighbors of E? We have A, we have C and we have D. Now we have to pick a node randomly from this particular set. What is the set here? Set is A, C and D. We'll pick a node randomly. We have picked A and incremented its counter. So now we have A2, B0, C0, D0, E1, F1, G0. So what do you think here? Is this the final page rank? The values that we have mentioned here? No. We have to keep iterating it, this random walk method. We have to keep reiterating it as many number of times as we can, and at the end our page rank values will be same as the actual page rank values. So next we will look for the neighbors of A. So what are the neighbors of A? We have again G, we have F, and we have B. So we will pick a node randomly from this set. So we have picked B and we have incremented its counter 2. Then what are the neighbors of B? We have only C as the neighbor of B. So we will traverse C and increment its counter. So we have traversed C and we have incremented its counter 2. Then as you can see, C is a sink here. What do I mean by sink? C is a sink here. It has no outgoing edges. So what we can do here? If we encounter a sink in graph, we will pick a node randomly from the given set of nodes. So we will pick a node randomly from the given set of nodes. What is the set here? A, B, C, D, E, F, G. You can pick any node from the nodes of a graph. So next we picked D here. So D, we picked D and we incremented its counter 2. Then we will look for the neighbors of D. What are the neighbors? We only have C as the neighbor of D. So we will pick C and we increment its counter. So we picked C and we incremented its counter. Then we again came to C and it is a sink. It has no outgoing edges. So next we need to pick a node randomly from the set A, B, C, D, E, F, G. So we picked F and we incremented its counter. Then we will look for the neighbors of F. What are the neighbors of F? We have E and we have G. So next we picked G as the node and we incremented its counter 2. So in this way you keep on traversing the graph for many number of iterations, and at the end the values that we have shown here will reflect the page rank values. Yes, so how can you be sure of this method? Well, we'll be simulating it, we'll be implementing this method, and we'll be showing you that this random walk method actually reflects the right page rank values. So let us move towards the programming screencast of this page rank implementation, and you will be getting a clear idea of how this method works in practice. Thank you. Before we move to the programming screencast of PageRank, I'll be telling you how can you draw graphs using NetworkX. I hope you are familiar with the NetworkX library. We have simulated it in the Joy 6 degrees of separation. So if you haven't gone through the videos of NetworkX, I'll recommend you to go through the videos of NetworkX first. So first of all, let me show you how can you draw graphs using NetworkX. So as in always, we'll be importing the concerned library. We'll be importing NetworkX here. So I'll write import NetworkX as NX. Next, I'll be showing you various graphs that are available in NetworkX. So first of all is the barbell graph. So I'll write NX dot barbell graph. And in this you need to supply two parameters. I'll supply 4 and 2. You'll be getting to know why I'm supplying these two parameters here. Then I'll write NX. I should initialize the G variable here as this so that I can draw it. Barbell underscore graph and the two parameters. So now I'll draw this graph. NX dot draw G. So as you can see, we have the two communities here. We have two communities as which comprises of 4 nodes. So in this particular community we have 4 nodes, and in this particular community we have 4 nodes. So next, if I write 4 and 3, then what happens? Let's see. See, we have 4 nodes here, and in between we have 3 nodes. In this particular graph we wrote 2 and we had 2 nodes in between the two communities. So what does the first parameter represent here? It represents the number of nodes in a particular community, and the second parameter represents the number of nodes in between the two communities. So we will draw it again and you will get a clear idea of what is happening here. So this time I'll write 5 and 3 and then draw it. So 5 nodes here, 5 nodes here, and in between we have 3 nodes. So this is how a barbell graph works. Next I'll be telling you some more graphs. Next we'll be drawing a complete graph. So I'll write G is equal to nx dot complete underscore graph, and in this particular thing you need to supply what are the number of nodes. So I'll just supply 4 here. Let me draw it. Nx dot draw and G. So I have a complete graph and it comprises of 4 nodes. So those who don't know what is a complete graph, in a complete graph we have each node that is connected to its n-1 nodes. For example, if I pick this particular nodes, it should be connected to rest of the 3 nodes. So here I pick this node and it is connected to rest of the 3 nodes. So basically it is connected to the rest of the nodes except the node itself. That graph is called complete graph. So next, basically it has every possible edge that can be present in the graph except the parallel edges and the self loops. Next, what we need to do, I'll show you how can you draw a cycle graph. I'll write nx dot cycle graph, and in this also you need to supply what is the number of nodes here. So I'll write 5. Let me show you. Next you write nx dot draw G. So we have a cycle of 5 nodes. So what next? There is another graph available in NetworkX, and that is ladder graph. So I'll write nx dot ladder underscore graph, and you supply the one parameter here, and let us see what does this parameter do. And nx dot draw capital G. So we supplied 5 here and we have 5 nodes on each of its parallel edges. We have 5 nodes here and we have 5 nodes here. In this way you can draw a ladder graph. Next is a path graph. So I'll write G is equal to nx dot path underscore graph and supply the number of nodes present in this path graph. I'll say 6. Nx dot draw capital G. So you have a simple path comprising of 6 nodes. Then I'll draw a star graph. So what we'll do nx dot star underscore graph. And then I supplied a parameter here. Let us find out what does this parameter do. And then let me draw this particular graph. So since you supplied 5 here, we have 5 nodes as the sink nodes. I hope you know that what is sink. It doesn't have any outgoing edge. So there is a hub node at the center of this star graph, and we have 5 nodes as the outer sinks. As the outer nodes, we have 1, 2, 3, 4 and 5 as the outer nodes, and we have 1 sink. So whatever parameter you supply here, that becomes the outer nodes, and there is 1 hub node. So in this particular graph there will be n plus 1. There will be parameter plus 1 number of nodes. So if I supply 4 here, then there will be 5 nodes in the graph. 1 will be hub node and the 4 node, and there will be 4 outer nodes. So let me draw it again. So we have 4 outer nodes and we have 1 hub node here. So what next we need to do here is, next is we can draw a wheel graph also. So I'll just write G is equal to nx dot v underscore graph, and you supply 1 parameter here again. So we will draw this graph. So we have a wheel sort of thing. It is basically a 4-node graph, and it looks like a complete graph also. So it is a complete graph. So next we will do it for 5 nodes, and let us see what happens. So in this particular thing we also have 5 nodes, 1, 2, 3, 4 and 5, and we have 1, 2, 3, 4, 5, 6, 7 and 8 number of edges here. So you can see that it basically doesn't correspond to a complete graph. It has a central node and it is connected to each of its nodes. Let me do it for 6 node graph. So here also we have a central node and it is connected to its n-1 nodes. So this is how a wheel graph works. Then we also have some random graphs present in Network X. So let me show you one instance of random graph, and we'll be using this random graph for our implementation in PageRank. So I'll just write G is equal to GNP underscore random dot underscore graph, and here I have first parameter as the total number of nodes. For example, I wrote 5, and then there is a parameter that is the probability of edge creation. Next parameter is the probability of edge creation. I just wrote 0.5. So with probability 0.5 it will make an edge between 2 nodes, and with probability 0.5 it will not make an edge between 2 nodes. So the probability is equal. So next, sorry, I didn't write nx here, that's why it is showing an error. So next I need to draw this particular graph. So you can see we have 5 nodes here and it has drawn the edges randomly. So let me draw it again and it will show me a different graph, because this is a random graph and it is making edges randomly. So let me draw it again. So see, now we have a completely different graph. So we'll be using this particular graph for our implementation of random walk method in PageRank. Thank you.